Welcome back to the course on computer-aided decision support systems and application using big data analytics. Professor Deepu Philip has given a broad introduction about the course, about the big data analytics, what is it, and generally you have also studied some of the topics like normalization, the SQL commands and some database management systems. I would like to focus more on what is big data analytics, the life cycle of the big data analytics system, the team, and how does it differ from the normal data science or data analytics tools. So this week would more focus on big data analytics life cycle. The tiles broadly I will cover in this week would be information technology, that is the basic data analytics versus the big data. Then big data analytics team, who all are the stakeholders, what are their roles and responsibilities, what should be the size of the team depending upon the organization, depending upon the size of the data or the kind of the future prospective outputs you need to have. Then big data analytics life cycle, we keep on going in the forthcoming lectures. We will discuss different phases of it and how does the phases or the planning is imperative, is crucial, is vital before starting any project. This will be discussed in this week itself. Now, information technology versus big data. I would like to differentiate the data science or data analytics from the big data. Let me divide this into three parts. This is big data. We have data science and we have data analytics. When we say the word analytics, it is a general term which can broadly or majorly consider three major types. One is descriptive analytics, then you have predictive analytics, then you have prescriptive analytics. Descriptive means how do we describe the data, mean, mode, median, variance, the measures of central tendency, measures of the dispersion. All these are describing the data. What data do we have? We have primary, secondary sources of the data. The secondary sources are one which are available in some databases that we learned in the previous lectures, how to retrieve them, how to delete some of the points, how to recover, how to return to the previous positions. Primary data is the one that we create for own purpose. So these kinds of the data are there in descriptive one. Predictive is what is the forecast in the future, what do you think would come based upon the previous data mapping on the current scenario, what will we get in the future, it is predictive. Prescription is when you have causality, when you have something like regression models, like some heuristics to be right, then we prescribe, okay, this would be the future, in this these steps would lead to this kinds of output, these kinds of algorithms are written. Big data is the one where we have a large amount of data and analytics and data science are part of it, and big data is an extension to the existing analytics tools. So data science is a field that refers to collective processes. It talks about theories, the concepts, the tools and technologies that enable to analyze, review, extract the valuable knowledge or information from the raw metadata. So we get information, further knowledge from the raw data. So when I will come to the different positions or the roles in the analytics team which is there, we will talk about data scientist and data engineer. The basic role or the basic purpose or the basic skills, the technical skills are to be there with data scientists who understand what is the raw data, who understand what is programming, who understand all the commands that you are trying to learn in this course. That is the starting position, data science. Data engineer is the one who does the data analytics. He broadly understands the things little more than data scientists only, because data scientists majorly know the subject matter, the expertise, the analytical solutions or techniques or so. The data engineer should understand this SQL, data management, that is the broadly the things that it does. So data analytics is the process of examining the data sets. examining the data sets, so in order to draw some inferences about the information, that what kind of input or information does this data has. So they have some specialized systems which help to get the output or the conclusions out of the existing data sets. Big data refers to the voluminous data. Voluminous data, that is, we talked about a few points here in the previous lecture: velocity, then volume, variety. This is for the structured data, and for the unstructured data as well. Sometimes the things are not in a very streamlined way, but still the data is available in a volatile manner, volatility and variance is high. A variety of data is available. So when this kind of data is available, so it is an extension to the next step when we go to the big data, and that is how it differs. So a few examples of simple data science would be digital advertisements, the internet search that you do, the recommender system in the internet that is there, okay, the next movie or the next program, next purchase that you should do, that could be helpful with the data science itself. If you are a small startup, you need to understand, okay, what kind of the products are available in the market, what kinds of the similar products. For example, if you need to sell a medical device that you have developed. I'll take an example of the oxygen concentrator development in the forthcoming weeks as an example in the big data risk management systems. So how do we manage risks while developing a medical device, for example, the oxygen concentrator. For example, if you have developed an oxygen concentrator, who would use it? In what scenario could it be used? These could be taken from the existing data points. So this could be simply done by a simple internet search. So that could come in data science. However, the detailed study could go to the big data. So basically, the data science person should understand the basic technical languages such as Python, such as they should understand the platforms such as SAS, SPSS, the basic commands, or SQL. I would also put SPSS here as well with the data analytics person. So data analytics or the data engineer could understand SPSS. If I talk about the open source softwares or some tools like Tableau could also be put in the skill set. Then we have Spark. Here comes the most used software, or the most popular in a way. Most used is a lower word. Most popular in this would be Hadoop, which the big pioneer, big tycoons have used, like Netflix, like Walmart. These big tycoons have been using Hadoop because they started the data science, they started the data analytics and the big data analytics in its incipient stage itself. We understood the volume, the potential what big data could bring to the market, to their sales, to their overall output. So they started using these things. Hadoop was the one of the base or the one of the initial software which were used. Now NoSQL databases are available. Similarly, the multiple databases also available. So these are the major differences between data sciences, analytics and big data analytics. How does the platform of the big data looks like? If I talk about the problem solution, system, you will see a traditional or just a data analytics systems generally what has is, it has a processor in which the input data comes. Let me say this is database 1, we have database 2. This database could be an Oracle based data, or maybe it could be a NoSQL data, right? It goes as input in the system. One has to clean the data first, data cleansing, then we do predictive analytics, then once the predictive analytics is taken, it goes to the, or it creates a new database which can be presented to the project sponsor or the upper hierarchy level, that is we use some visualization tools. Visualization, I will discuss about the data visualization, what kinds of tables, what kinds of the graphics do we use to present the data. There are different ways to choose, when to choose a pie chart, when to choose a line diagram, when to choose a histogram, or maybe some more detailed charts such as we have box plots or so, when and where to choose them. This also we will discuss, because data, once it is analyzed and we have the output ready with us, as a scientist, as an engineer, you will be able to understand what output you are trying to present. But the team, the experts, or the financiers would like to understand that in a visual form. To make the upper level of hierarchy understand what data or what output are you trying to present to them, visualization is vital. What kind of charts you will present, this we will see. So visualization, then you have here a report. A report, that is the output that you have. This is a scenario for the general data analytics system. Now comes your big data analytics systems. In this case also you would have a few databases, database 1, database 2, again it could be Oracle, NoSQL, Cassandra, or anything like that. This goes inside the processing system. Now here I will put the word ETL. ETL is extract, transform and load. I will talk about ETLT as well. Extract, transform, load, transform, what are differences that we will discuss in the forthcoming lectures in this week itself. Now this database 1 and database 2 goes and input to the processing system. It does not go to the data cleansing directly as was in the case 1 above. So this is case 2, case 2 actually the process 2, which is for big data analytics system, in which this input goes here to the processing system. Along with this we have archived data. Archived data, that is the previous data which is generally thought of no use in the general data analytics system, because in the general data analytics system we only opt to have very small crunches of the data. The data, a very few lines of the input, or very small amount which we think are only significant would only be used, but data which is not recovered, which is archived or which is previous, maybe only the recent weeks are taken, recent times are only taken in the general data analytics system. Yes, recent times, recent weeks data, let me take in the case of suppose retail in the forecast or so, is important for the data analytics, in the big data analytics as well. But the previous data, the previous year's data, previous month's data, data a few decades back is also taken to understand what were the trends, how would the season change, how would the things would impact to the forthcoming sales as well. So that is why archive data is also taken as an input here, right. So this is input here, this input goes to the processing system. So this is my processing system, this large box. So here the ETL or ETLT systems helps us to have different predictive analytics. Predictive analytics 1, then similarly I do have similar predictive analytics and predictive analytics here. this goes to the big database and this is an enclosure in our overall big data analytics system. So this is my database again and these inputs go here. Finally, we have data visualization and a report. Right. So this is my big data analytics system. So broadly, if I say in big data analytics system, the archived or the historical data is also taken. This is one. Second is we have not cleansed all the data, we just extract, transform and load the data as and when required. We keep on taking points and the whole process is divided into small work breakdown structures. So this small data, that is, suppose if I designed a small algorithm in which out of this, let me say 20 petabytes of data is there, I have only selected 20 gigabytes of data, made a small program. This program will be repeated time and again. Once this program is tested, validated, so we have to define training, testing and validation data. How do we do that? We will come to the points. So it is repeated multiple number of times to process the whole available 20 petabytes of data. This is large and big amount that I am talking about. So this is how big data analytics work. So what are these? Let us talk about the life cycle. Before that, let us talk about the roles and responsibilities of the big analytics team. Big data analytics team, because it is big data, we are talking about the large or volume of data in which the velocity could also be high, in which the variety could also be high. The team vary from the number of people from 3 to 20 in general. It depends upon the big companies like Walmart, which has more than 2 million of employees, can have team of hundreds of thousands of people, maybe hundreds of people who are specifically working in the big data analytics part of the company. So the team basic roles would be similar. So I have now delineated roles into the different ways here. For instance, first role could be data scientist. As I talked about this in the previous slide as well, data scientist is the one who provides the subject matter expertise. Now we have also with him is data engineer. Data engineers who should be able to understand the at least SQL queries or data management, data extraction, then support for data ingestions into the analytics sandbox. So these things the person should know. Above them is a database administrator. Database administrator is one who configures the database environment to support the analytics needs of the working team. Now with them we also have the business intelligence analyst. To jot down the roles, let me put here, data scientist has basic subject knowledge, right, programming languages, right, then data modeling. In a nutshell, it should know the analytical techniques. Data engineer should be able to maybe SQL or similar languages he should know for the data management. Management is a very wide term here. By management I say extract, ingest, delete, etc. the person should know, so that he keeps on guiding the data scientist that what are the things the person needs to do or not. Yes, these two roles are interchangeable in a way. In a small team, data engineer and data scientist, both the jobs could be done by a similar person or a same person. Database administrator is the one who has more broad information. He is database administrators who might have 2 or 3 data engineers working under him, and he should be able to take the responsibility for providing the access to the data for the data engineers or scientists. Then key tables or key databases which are required, he should be able to select them as well. Select for the team, select the data for the team. Now comes the business intelligence analyst. Business intelligence analyst is the one who understand what is the business, what are the key metrics. Now there is something known as KPI, key performance indicators. KPIs are defined, KPIs are measured, KPIs are quantified. Okay, for instance, applying this algorithm, the sales should rise by 100 pieces per day. This is a key performance indicator. Applying this technique, the employee retention in our company should be increased by 20%. This is a key performance, specifically 20%, 100 pieces per day. These performance indicators are only defined by business intelligence analyst. So key performance indicators are defined by him. Also they put key metrics. These metrics are put from the business intelligence viewpoint, that is how to create different dashboards and reports and have knowledge about the different data feeds and resources. Now understanding the data visualization, sometimes data scientists might miss those points. Data visualization, what to present, what kind of graphs to present. One figure could give us an information that 1,000 words could not. That figure, what is that figure, where to put the different data points, what are the different metrics, how do we label them. Business intelligence analyst should understand, because he has read multiple reports, multiple books, and he should be able to understand and try to present this to other roles. So these are all supported by the person who is trying to manage everything. Project manager. Project manager might not be a core expert in big data analytics, but he is overall managing the project, because he has to see what are the objectives and milestones. So these are all to be met in time. This is his role. We cannot run any project without a sponsor. Project sponsor who provide the finances. Always included are the people who are going to use that, the data. We provide also the business user. For instance, in a manufacturing concern itself, I had a chance to work with Hero Cycles. In there, whatever bicycles were produced, first they were given only to the people who are within the company itself. Maybe the milk vendors or the small vendors who used to deliver newspapers or the milk within the Hero Cycles plant itself at Ludhiana. So these internal users gives us the input or the feedback. What is the overall performance of the bicycle? If we try to use it in a very bashing way, how would it break or not? So these kind of business users are identified. Sometimes they are internal users, sometimes they are the people who are identified as the users only, but they are paid for it. For example, Netflix pay the people to watch movies and tag some points wherever the people pause or people stop watching on it. So this is something that is very important for the overall business as well. So their key roles. Project manager is, milestones are set right. The key indicators or the key performance indicators are given by the business intelligence analyst, but milestones are met in time, timelines, right? Then allowances, these are all given by the project manager. Allowances means if the timeline is 1 week, it could be 1 week plus minus 1 day, something like that. Project sponsor, he understands what is the total budget of it, right? The budget project manager also knows, but the financing is to be done by the project sponsor. So where the funding is coming or who is going to finance it. Project sponsor actually understand what is the market, what does the market need. So he is investing in something. This investment, he doesn't know anything, or maybe he knows very small thing about what is big data or what is analytics or so. The person is putting the money. So project sponsor knows that by the past experiences, or there are example company who has used this kind of the procedures, this kind of algorithms to come up with the profit of this level. So that profit plus minus 5% or so he would only expect to have. So he understands what market is there. Big data, specifically technical information, the person might not have, but as an executive summary he knows everything what is going on in the system. Now next is a business user. Business user is the one who understands the domain area of business, right? So this is a person who can consult or who can advise the project team on the overall context of the project, or what value the, I would put BDA as big data analytics, the value the BDA is bringing to the customer. So these are the key roles or key analytics team members. 7 roles are there majorly that I have bought. The positions or the name of the roles could be different. It could be project place of project sponsor, it could be the financer, it could be the owner, it could be the managing director or so. So business user could be the final user, or maybe in the gaming business the person who plays the games for the company and tries to give the feedback, the new inputs that could come. So different kinds of roles, different kinds of positions are there, but majorly these 7 roles are there. In a team of 3, a few roles are clubbed. For example, data engineer, data scientist could be 1, business intelligence analyst and project manager could be 1, sponsor and project manager could also be 1. In a team bigger, we can have multiple engineers or scientists, maybe 20 or 30 scientists working under a single project engineer, or I would say data engineer. These roles are there in general. So with this I would like to have a pause in this lecture, and I will continue in the second part of this week, in which I will try to explain the big data analytics life cycle. Thank you.